Hello, welcome everybody to my presentation on what developers care to recall, interview server on small systems. That's a collaboration with Regina Hebig and myself. And as you can see in the top right corner, all the results, all the guides we use here are in the Zenodo repository, so you can use them yourself and you can check our results basically and validate what we found. So to get started, this study basically originates from an ICSI paper 2018 where we investigated how developers forget source code of their systems. And we found that different factors basically impact their memory, for example, how often they worked on the code, how much of the contribution are actually their own. And we employed a forgetting curve to see how we can measure memory decay. However, some of the discussions that came up with Regina was basically, it's unclear whether it may be aligned to what knowledge developers consider important to remember and whether different kinds of knowledge have a different impact on the memory and whether they are just better to remember or not. So whether the code knowledge is basically really the important part. So we decided to conduct a systematic literature review and an interview survey to answer 3 research questions. That is, what knowledge developers consider important to remember, whether developers can correctly answer questions based on their memory, and whether they are reliable in assessing the knowledge they still have, so a self-assessment basically. And all that helps to understand and scope program comprehension and knowledge recovery research. So to focus more on specific types of knowledge, for example. So as a first step, we conducted a systematic literature review, and we started with the 5 papers that are asterisked here. And we did forwards and backwards snowballing and identified a number of papers that specify concrete questions on software evolution maintenance or development. So for example, we removed papers on security aspects and removed questions on code reviews. And in the end, we basically had these papers here with a diverse set of research methods, a diverse set of concrete questions. And we basically had 3 scopes, that is identifying questions, rating the importance of questions, and rating the difficulty to answer questions. All of that we used to design our survey and to verify our results. And the survey basically comprised of 5 sections. The first section was focusing on the self-assessment, so we asked the developers to assess their remaining knowledge about their systems on different categories, and we repeated these questions after each of the following 3 sections. The second section was basically on architectural knowledge, and here, for example, we asked them to draw architecture of the system. Then the second section was on meta knowledge, and here we asked about collaborative work, for example, when has a file last been changed in the lifecycle of the project. Then we asked about code comprehension, that we put into 2 different categories. The first one being on higher levels, so what is the intention of the code in a file, whereas the second part is basically on more fine-grained knowledge, like what is the parameters or code smells in a method. And we asked this for multiple files. The last part is rating the importance of knowledge. We basically did this in the end to avoid any biases and that would threaten our results, because, for example, developers would try to confirm that the rated question is important and try to really focus on answering that one. And here we basically let them rate the importance of the sections and all the questions. And for the interviews, actually we conducted 17 of them and we reached saturation, so we gained no new insights for the last 3, 4, 5 instances of conducting our survey. And you can see it's a really diverse set, different areas, different domains, different programming languages. However, mainly smaller systems with few developers, so that's why our analysis is mainly focused on smaller systems. So considering the results, first we have the importance of remembering knowledge, and we can see here that architectural knowledge was considered more important than the other types of knowledge, especially drawing the architecture. The first question received basically only important ratings from everybody, whereas meta knowledge was considered less important, or least important actually, but that actually, as said previously, may be due to the smaller systems we investigated. For the code knowledge, we actually find that we have exactly those 2 patterns for the 2 different categories we designed. So the first one, the higher knowledge, received higher ratings considering the importance, whereas the second part considered really lower ratings considering the importance. So intentions, for example, are more important to remember apparently than code details. As said, this may be threatened due to the small systems. However, all that aligns to the literature we found in the literature review, so that improves our confidence that the results are reliable. Second, we are interested in the correctness of answering questions from memory. And here we can see that all of the participants achieved really high scores, roughly 80%. Also that the correctness aligns with the importance they rated the question on. So particularly on the code level, we can see again those two different patterns we had. Like higher level questions on intentions, they could answer more often correctly, whereas the lower level things on parameters, code smells, they could answer correctly less often. So that's really interesting. And we then checked, because of the ICSI 2018 paper where we investigated the memory decay over time, whether that may be just due to the time that has passed since they last checked the files. So on code level, we actually find the memory decay is not the important factor here, so it really seems to be those different kinds of knowledge we ask for, higher level versus lower level. For the third research question, that was on the self-assessments, we here show the self-assessment as an initial question and after the last section, so after the code comprehension questions, and we can see here that the ratings received similar, however they decreased upon reflection. So that may be an indication of saying the more you know you don't know. So after reflecting, you are basically more aware of what you are missing in your knowledge. However, we find a positive tendency, no correlation, not enough participants for that, but the self-assessment aligns to the correctness our participants achieved. For actually assessing the self-assessment, all participants assess the architecture, the efforts they spent on developing the system, as well as the intentions of the code. So similar aspects as we found previously. However, some simply guessed, so that may not be an ideal indication for some empirical guidelines that use self-assessments. So to summarize, we basically provide guidance for practice how to manage and disseminate knowledge. So for example, we have differences on architectures and intentions that are most likely more tacit and important to remember, so they should improve the traceability here, whereas code details like method parameters and so on, where it's arguably more important to perform comprehension and clean code guidance. And we have difference between experts that have tacit knowledge and novices that need this knowledge, but it may not be available. Then we have important insights on, developers can recall knowledge better they consider important, but the self-assessment also seems to be reliable. Or that seems to be really important. And the main contributions are open research directions for the future that we will investigate, different knowledge needs in different contexts, how to provide tailored knowledge support, for example, for experts and novices, how to understand, then we need to understand what importance implies, whether it's just difficult to answer or really important for a specific task, and investigate how developers forget different types of knowledge. Thank you very much for your attention.